It is still September 13th. This is one of our last runs. I have an ammeter. I have the bolts removed so that they won't vibrate down. I think I've got all the various things. I think I'm about take 7 on this one. One of the previous takes, we had a hardware fault on the throttle. The exact message on power up was throttle out of range, exclamation mark, is it unplugged? Config showed a value of 0, even though the throttle had not changed. I wiggled it back and forth a little bit, and I then got a value of approximately 500. But it wouldn't do a run rotor test after that. So 548 is exactly what it was. So what I'm doing now is I'm capturing to FOC test 6 and powered up the controller. I'm going to type config. I've got 2 pole pairs, which is what I want to test. I'm just going to do a run rotor test. And you can hear the noise starting. The amps, we're at 2.3, 2.4 amps on our DC bus. We're up to 3.7. I'm just going to check field of view and see whether that's visible. It's small, but it's visible. It's on this this clamp-on fluke down here. The voltage on the bus on the Greenlee up top, on top of the ring capacitor, is 125.2. It doesn't really stray too much from that. So I'm not sure why the other meter, the less expensive Mastercraft meter, was so susceptible to the noise, but the Greenlee does not seem to be at all. So this run, once we get value and choose an index, I'm going to spin up the motor. I'm still having trouble finding my tachometer, so I won't have speed feedback. But we'll do DC amps going in and AC amps going out with the clamp on. See whether there's a big burst of energy when we're accelerating and decelerating. I expect that there will be. And we're at 3.8 amps on the 125.2 volt DC bus. Still at 3.8 amps, still at 125.2 volts. We'll flicker to 125.1 once in a while. .9 amps on the DC bus. And now we're turning quite smoothly down to 125.1. Actually taking some current here. Just bouncing up to 4 amps. We had a little bit of wiggle going back and forth. Although starting and stopping several times seems to have gotten my coupler aligned with the encoder quite well. We're at 4.1 amps, still 125.1, 4.2, 4.3. 4.4 or 4.5, 4.6, 4.7. A bit of vibration here, 4.95. Vibration should be dropping off now. 5.2, 5.3, 5.5, 5.6. 6.2 amps, 6.5, 6.8, 124.8 volts, 7.5 amps, 8 amps, 124.7 volts, 9.2 amps, 10 amps, 10.7 amps, 120, well, we're dropped to 2.8, 2.9 amps, and just wait for the noise to go away a little bit. Then we're back down to 2.9 amps. That seems to be what we're at. I'm just going to take the meter off. It shows minus 0.2, so the number should have been pretty close. Oh, maybe we had, maybe I should have had it down there. Looks like the clamps were open a little bit, so our number could have been a little high. We're at 0.2 amps right now. The highest number I got on the test is the last one, 890. I believe that there is 50 numbers in the index, 50 that are tried. And then we'll just count again, make sure. So we're going to choose, after I type in config, we are going to go with rotor, time, constant, index, 49, which is the second highest number or the highest number depending on whether we're starting at 0 or 1. I actually can't remember whether we started at 0 or 1. So right now we're at 0.2 amps. I am going to twist my throttle. We're at 12, 15, 18, 20, 24, 25, 29, 34. That was a little bit scary. Oh dear. And I was trying to do max regen there, and I got my throttle too low, and I didn't get any regen at all. So I have, there was some hardware caused fault, not originating on the microcontroller, not set by me, and throttle out of range, is it unplugged? Which, of course, is an issue because we have to cycle power in order to get the fault cleared. Next time I do this, I guess I'm going to be a little less aggressive on the throttle, and maybe bring the throttle a little closer over where I can still see the current. Anyway, stop that one. Transfer, capture, test 7. Stop the video and start it again.